Now we are going to study the MCQs of the digital electronics. So you can read here problem number 1. The diagram shows the combination of the logic gates. Input P is at a logic state 0, that is nothing but low, and input Q is at logic state 1, that is nothing but high. What are the logic states at output X and output Y? So this combination of the logic gates is given over here, and in digital electronics we have learned several kinds of logic gates. Out of them, three logic gates are used over here. You can see this one is nothing but the NOT gate, this is the NAND gate, and this is nothing but NOR gate. And for reference, I have attached here the truth tables of the NOT gate, NAND gate, and the NOR gate. You can study, and you have to see all the gates once again in the lecture video to solve the MCQs and the structure problems of the logic gates. Here these are the two inputs, P and Q are the inputs, X and Y are nothing but the outputs. So at input P it is nothing but 0. We have in the inputs in the logic gates we have either 0 or 1. So here 0 is input for the P, 1 is the input for the Q. So inputs are given, and we need to find out what is the output X and Y. So here see, this is nothing but the NOT gate, and you can see here this input for the NOT gate is 0. So what should be the output? So you can see this truth table. For 0 we are getting 1 as the output. So the output of the NOT gate here, it will be 1. So I will write here for reference, it is nothing but the 1. Okay, and that output is going to be the input here for this NAND gate. For NAND gate we get actually two inputs. For NOT it is only one, but for NAND we need two inputs. So here one of the input is nothing but 1, which is nothing but the output from this NOT gate. And what is the another input here? Another input is coming out from this Q input. So Q input is what? It is nothing but 1. So this will be the input. Here you can see this is the common junction. This one is the common junction, and here it is the input for NAND gate. So NAND gate another input is nothing but 1. Okay, it is coming from this input Q. Again you can see this is the common junction, so it is again the input for this another gate, which is nothing but the NOR gate. So here also the input is, one of the input is 1. Another input is coming from the output of this NAND gate. Here this is a NAND gate, and two inputs are nothing but 1 and 1. So here you can see this is the truth table of the NAND gate. If the two inputs are 1 and 1, you can see the last here row. If the two inputs are 1 and 1, the output is nothing but 0. So here the output I will write over here, it is nothing but 0. Now this 0 is nothing but the output X, because this is a common junction, it is nothing but the output X, and also it is here, it will be coming like this, and it is a input for this NOR gate as well. Okay, it is nothing but 0. Okay, so we get now two inputs for this NOR gate. One is coming from the output of the NAND gate, and one is coming directly from the Q. So what are the inputs for NOT gate now? It is 0 and 1. And now here you can see the truth table of the NOT gate. The inputs 0 and 1. You can see this input is 0 and 1. And for that output is nothing but 0. So here I will write the output of the NOR gate. It is nothing but 0. Okay, so I hope you understood this combination here. The junction meaning it is going to be same for both the paths. Here also it is going to be same for both the paths. And here what outputs we are getting, at output X it is 0, at output Y also it is 0, and in the options you can see the output X and Y, it is 0 for option number 1. So option number 1 is the correct answer. Now we will see the problem number 2. Which symbol represents the AND gate? So which one is the AND gate over here? What is this gate? It is nothing but the NOR gate we have just seen, it is nothing but the NOR gate. This one, you can see this one, it is nothing but the NOR gate. What is this? This is nothing but the OR gate. Okay, this is OR gate. This is NAND gate. We had also seen over here, this is nothing but the NAND gate. So if you remove this circle, okay, this dot from the NOR gate, it becomes actually the OR gate. This is the NAND gate. And what is this? If you remove this, again this small circle from the NAND gate, this becomes the AND gate. So this is our symbol for the AND gate. Okay, we are finishing our MCQs for digital electronics here. Now we will see the structured problems. Now we will see the structured problems for the digital electronics. Here you can read the question number 1. Figure 10.1 shows the symbol for the circuit component and you have to name the component. So which component is this? So here you can see this all components we had seen in the electric circuit chapter, and this I am going to attach here for the reference. So you can see over here in that case, this is our answer. This one is our answer, which is nothing but the light emitting diode. So we have to write over here. You can write down either LED directly or light emitting diode, both the ways. So I will write here light emitting diode, or also you can put it over directly LED. Okay, so here question number B. In the space below, draw the symbol for the NOT gate. Okay. In the MCQ we had seen the symbol for the NOT gate. All the symbols of the gate we have to revise before we are going to solve any problem in the digital electronics. So what was the NOT gate basically? We had seen it is nothing but the only the kind of triangle we are getting in that case. So here I am going to draw the triangle. Can draw like this. And there is a one small circle. We are getting small dot over here. Okay, here in case of the NOT gate, only one input you will get over here. This is the input, and this one is nothing but the output. Okay, so this is the symbol for the NOT gate. This is the symbol for this NOT gate. Okay, now we will move towards the part B of the problem. Here in figure 10.2, which shows the digital circuit, okay, and you have to complete the truth table for this circuit. Okay. So this is a circuit given, and you can see two kinds of gate are attached in this circuit. So this gate is nothing but the AND gate, and this gate is nothing but the OR gate. Okay, if you put dots over here, then it becomes the NAND gate. If you put the dot over here, it becomes the NOR gate that we had seen in the MCQ. So we are removing that dots, then it becomes the AND gate and it becomes the OR gate. Okay, and we have to complete this truth table which is given over here. So here we are for the AND gate we need the two inputs. So this inputs A and B, these inputs are the inputs for the AND gate, and for OR gate also we need the two inputs. Here D is the input for the OR gate, and C, which is the output of the AND gate, becomes the input, another input for the OR gate. Okay, and from C and D, okay, C and D, these are the inputs of the OR gate. From that C and D, we get the E as the output from this OR gate, or which is our final output of the entire circuit. So the truth table for the AND gate is given over here for reference, and the truth table for OR gate is also given here for the reference. So it is a very simple circuit. If you go step by step, then you can feel it is a very easy. Here, first of all, we will find out this. We will first of all find out this output C. Okay, and then we will consider C and D as the inputs, and then at last we will find out this output E. So our goal is to find out just the output C as of now, which is the output of this AND gate, and the inputs are what? A and B. And here you can see in the